So for this problem, to find the 8th term and the 25th term in the geometric sequence, so given the 5th term and the 10th term, so writing this geometric sequence, so this is the first term, this one is the 5th term, and the 10th term. So since the 5th term is equal to positive 6 and the 10th term is equal to negative 192, then to find the 8th term, so this one is the unknown. So observe that in the sequence, the first term or a sub 1 is unknown. So therefore, we're going to use this formula. So that's a sub m equals a sub m because there is no given first term. So from this formula, a sub n is the last term and the last term is the 10th term. So therefore, this is also equal to a sub n. So a sub n is equal to a sub 10, and this is equal to negative 192. So therefore, n is equal to 10. Then for this a sub m, so since a sub n is the last term, so therefore this a sub m is the other given term, and that is equal to a sub 5. So a sub m equals a sub 5, and this is equal to positive 6. So therefore, m is equal to 5. Then from this given, we can find now the common ratio. So substitute now all these values using this formula. So we have a sub n is equal to negative 192, then equals a sub m is equal to positive 6, then times the common ratio to the power n, and n is equal to 10 minus m, and m is equal to 5. Then to simplify, so divide both sides by this positive 6, so divide by positive 6, then cancel. So this negative 192 divided by 6. So we have negative 192 divided by 6. So that's equal to negative 32. So this is equal to negative 32, then equals. So this is r to the power 10 minus 5. This is positive 5. Then to solve for the common ratio, so since the exponent is 5, so we need to multiply the exponent by 1 over 5, and also this negative 32 raised to 1 over 5. So we can cancel now this exponent. So we have r, or the common ratio, equals, so this negative 32 to the power 1 over 5. So we have open parenthesis, negative 32, then closed parenthesis, then to the power, open parenthesis, 1 divide by 5. So that's 1 over 5, then close parenthesis, equal. So this is equal to negative 2. So the common ratio is negative 2. Then since we have now the common ratio, so we can find now the 8th term, or a sub 8. So to solve for a sub 8, so we can ignore now this 10th term. So this time the last term is a sub 8. So we have A sub n equals A sub 8, and this is equal to, or the unknown, therefore n is equal to 8. Then for A sub m, that's also equal to A sub 5, and this is equal to 6, and m is equal to 5. So to solve now for the 8th term, so we have A sub n, so that's A sub 8 equals A sub m, that's 16 times the common ratio, that's negative 2, then to the power n minus m. So n is 8 minus m is 5. So this becomes A sub 8 equals 16 times the negative 2 to the power this 8 minus 5 to the power 3. Then we have now A sub 8 equals 16 times. So this negative 2 to the power 3, this one is negative 8. So therefore, A sub 8, or the 8th term, equals negative 48. Then this time to find the 25th term. So this is now the 25th term, the A sub 25. So we can ignore now the 8th term. So therefore, A sub n becomes A sub 25. So from the given, so A sub n equals A sub 25. And again, this one is the unknown. Therefore, n is equal to 25. Then for A sub m, so A sub m the same A sub 5, and this is equal to 6. Therefore, m is equal to 5. So to find out the 25th term, again r, or the common ratio, this is negative 2. So we have A sub n, this one is A sub 25 equals A sub m. So A sub m is 6, then times the common ratio. So this one is negative 2, then n is 25 minus m is 5. So this becomes A sub 25 equals 6 times negative 2 to the power 20. So that's 25 minus 5. Then we have A sub 25 equals 6, then times. So this negative 2 to the power 20. So again, since negative, so we need to put inside the parentheses, then to the power 20. So that's equal to 1,048,576. So 1,048,576. So we have now A sub 25 equals, so times 6. So this 1,048,576 times 6. So that's 6,291,456. So 6,291,456. So this is now the value for the 25th term.